Everyone, welcome back. This is the first video in the series of ASR. ASR stands for automatic speech recognition. How do we have robots that listen and speak? It's due to ASR. So let's get started. How do we categorize ASR, or speech recognition? Speech recognition is under sequence modeling. Sequence modeling is under deep learning. Deep learning being under machine learning. Machine learning being under the artificial intelligence. Artificial intelligence is the broad science of creating systems that can perform tasks typically requiring human intelligence. Machine learning is a subset of AI where machines learn from data to improve performance on a task without being explicitly programmed. Deep learning is a subset of machine learning based on neural networks with many layers, hence deep. Sequence modeling is a class of deep learning focused on the data that comes in sequences. That's where all that matters. Speech recognition is the application of sequence modeling. Sequence modeling being a branch of deep learning to convert speech into text. The workflow of speech recognition goes as follows. There is an audio input, like microphone, like an audio file. Then it will be processed, and then it passed to the model for analysis. And the output will be decoded, and we'll get text. Let's build an automatic speech recognition now. In today's practice, we'll generate lyrics for the Fight Song by Rachel Platten. Since we'll be using Python, it's recommended to create a virtual environment. That's helpful, especially if you have different versions of Python in your computer. This is how we do it. We'll create a virtual environment and call it FFmpeg, then activate it. This is how we activate the environment on macOS or Linux. And this is how we activate the environment on Windows. The second step will be installing the required libraries. That's Torch, Whisper, and FFmpeg. Just pip install Torch, pip install faster Whisper. Today we'll use a faster Whisper. For some reasons, I chose to start with faster Whisper. There's OpenAI Whisper, but OpenAI Whisper has some setbacks. Like, it will throw this warning. Some people like me don't like warnings. If you try, you will see that the output of what it does is not fine-tuned too. Faster Whisper has its own way of sparing us of warnings, and the output text is fine-tuned. You also need to install, if you didn't do so before, FFmpeg. This is how we install it on macOS. This is how we install FFmpeg on Linux, and this is how we install it for Windows users. We just go to FFmpeg.org and we download it, and during the installation we make sure we add it to path. Okay. This is the code. You have the same code at my GitHub account, so don't worry. And when you run this code for the first time, it will take a while, and this is what it will be doing for the first time. It will be downloading the model and saving it in the cache. Well, what does it download? It downloads config.json, vocabulary.txt, tokenizer.json, and model.bin. Well, it will save it in the cache. In my case, here is the cache. So I'm in the cache. So in the cache, or I can just use tree. I have config.json, model.bin, tokenizer.json, vocabulary.txt. So let's see what config.json contains. Let's open it with VS Code. This is what we have. Say element heads, language IDs. Now, this is the IDs of the languages, and suppress IDs, and then finally suppress IDs begin. This is what it has. I don't think you need to look at model bin, because this is the binary. Let's try and open binary. Yeah, we can't open a binary using VS Code. And see. This is what's in the binary. Model binary. This is the knowledge itself. The knowledge itself. I mean the knowledge pack. Okay. I will stop it. Control C. Okay. Then let's see what's in the tokenizer.json. Let's open it with code. Okay. So let's try and find some words. Let's check, for example, the current president of the United States, Donald Trump. get Trump with capital letter. Yeah, he has this token. Let's check for Biden. Biden's here. And let's check for Obama. Obama is here. Let's check for Putin. Putin computing. Putin. Yeah. Let's check for Tesla. Tesla is here. And let's check for Elon Musk. Musk is here. Okay. What do you have in tokenizer.json? We have words and the assigned tokens. But as you can see, for example, a reserve, we have an encoder, kind of encoder. But for example, count doesn't have an encoder. Some words start by this kind of encoding. Yeah, but others don't have, like OK doesn't have. Okay, that was the exploration. So as we've seen, config.json describes the model's architecture, number of layers, hidden size, attention heads. Vocabulary.txt contains a list of tokens or words the model recognizes, essentially for decoding. Tokenizer.json contains rules for converting raw audio to or text token and vice versa. So tokenizer.json will handle both directions because it's the bridge between text and numerical world of the model. It will convert text to like Murahoneza in Kinyarwanda into tokens ID, like this number as we've seen it. And that why? Because neural networks can understand words. It only understands numbers. So we need to tokenize the text. And when the time comes to convert the token to the well, we convert a token. We'll convert a token like 4852 to readable text like Murahoneza or Muraho. And why? Because after all, even though the model thinks in tokens, IDs, we are humans and we need something readable as humans. Okay, before we close, let's talk about Hugging Face. We downloaded the model from Hugging Face. Yeah, it's shown here. In the cache, we say we have Hugging Face, Hub, then models. What if we go a little bit back and ls and back again, ls, but what if you go back again, ls, and where are we? Print working directory. We are in the Hugging Face hub. Let's get back. ls twd print working directory. We are in Hugging Face, and we have firmware, hub, metrics, and modules. Let's go in the metrics just by curiosity to see what's in the metrics, because as long as you have a model, the model has been trained and there have been metrics to show if the training is successful. So let's look in CER, most less. Is it certificate? Let's see CDCR, and let's go into default. Nothing in the default. Back. Let's see in WEL ls cd default. There's nothing in the metrics. What does it mean? It means we didn't download the metrics. But if we train the model, like we'll do in the next videos, most probably the metrics will be saved here. So far we didn't see anything saved in the metrics. Okay. So we have Hugging Face. What's Hugging Face? Hugging Face is the platform powering modern AI models, making it easy to use, train, and share speech recognition systems, including Whisper. It's a model hub. Think of it like a GitHub, but for AI models. What is really Hugging Face? We search for existing models like Whisper, and we download pre-trained weights like we did today. We upload our fine-tuned models for our students or the world to use. Yeah. For example, the model Faster Whisper we are using today was uploaded by someone. Okay, I'll make more video. The objective is to help you design a robot that can listen and speak. As you know, our broader scope is intelligent robotics. That's why you have a robot that's learning something new instead of being explicitly programmed. So please remember, you always have code and documentation at our GitHub account. I hope you enjoyed the video. Until next time, bye.